A microcontroller is a compact integrated circuit designed to control specific functions in an embedded system. It typically contains a processor, memory, RAM, ROM, flash, and various peripheral interfaces such as ADC, DAC, UART, SPI, I2C, etc. There are several microcontroller architectures including Harvard architecture. It separates instruction and data memory spaces. This allows for faster processing and effective use of memory resources. Von Neumann architecture. It uses a single memory space for both instructions and data. This architecture is simpler to implement and less expensive but may result in reduced performance. RISC. Reduced Instruction Set Computing architecture. It uses a limited number of simple instructions that can be executed quickly. This allows for faster processing speeds and lower power consumption. CISC. Complex Instruction Set Computing architecture. It uses a large number of complex instructions that can perform multiple operations in a single instruction. This architecture offers more functionality but is generally slower. The choice of microcontroller architecture depends on the specific requirements of the embedded system, such as processing power, power consumption, and memory size. Here's a detailed explanation of each microcontroller architecture. Harvard architecture. The Harvard architecture is characterized by having separate memory spaces for instruction and data. This means that the program code is stored in one memory space and the data is stored in another. This allows the processor to fetch instructions and data simultaneously, resulting in faster processing. Advantages of Harvard architecture. Faster processing speed due to the ability to fetch instructions and data simultaneously. Improved memory utilization as separate memory spaces allow for effective use of resources. Better security as the code and data are stored in separate memory spaces, making it harder for an attacker to modify the code. Disadvantages of Harvard architecture. Increased complexity as separate memory spaces require more hardware resources. Higher cost due to the additional hardware required to implement separate memory spaces. Von Neumann architecture. The von Neumann architecture is characterized by having a single memory space for both instructions and data. This means that the program code and data are stored in the same memory space, and the processor fetches both instructions and data from the same memory location. Advantages of von Neumann architecture. Simplicity as only one memory space is required, making it easier to implement. Lower cost due to the reduced hardware requirements. Disadvantages of von Neumann architecture. Reduced processing speed as the processor must alternate between fetching instructions and data. Reduced memory utilization as the same memory space must be shared between instructions and data. RISC. Reduced Instruction Set Computing architecture. The RISC architecture is characterized by having a limited number of simple instructions that can be executed quickly. This allows for faster processing speeds and lower power consumption. Advantages of RISC architecture. Faster processing speed due to the simple instructions that can be executed quickly. Lower power consumption due to the reduced number of instructions required to perform a task. Improved performance as the simple instructions can be executed in parallel. Disadvantages of RISC architecture. Reduced functionality as the limited number of instructions may not be sufficient for all tasks. Increased complexity in software development as more instructions may be required to perform a task. CISC. Complex Instruction Set Computing architecture. The CISC architecture is characterized by having a large number of complex instructions that can perform multiple operations in a single instruction. This architecture offers more functionality but is generally slower. Advantages of CISC architecture. Increased functionality as the complex instructions can perform multiple operations in a single instruction. Simplified software development as fewer instructions are required to perform a task. Disadvantages of CISC architecture. Reduced processing speed as the complex instructions require more time to execute. Increased power consumption as the complex instructions require more resources. Increased complexity in hardware design as the complex instructions require more resources. Here are some examples of microcontroller architectures used in popular microcontroller boards. Harvard architecture, PIC microcontroller, peripheral interface controller, from microchip technology uses Harvard architecture. Von Neumann architecture, AVR microcontroller, Atmel AVR, used in Arduino boards is based on von Neumann architecture. RISC, reduced instruction set computing, architecture, ARM Cortex-M microcontroller series used in many microcontroller boards including the STM32, Street Microelectronics, and NXP-LPC, NXP semiconductors, are based on RISC architecture. CISC, complex instruction set computing, architecture, MSP430 microcontroller, Texas Instruments, is based on CISC architecture. These are just a few examples and there are many other microcontroller boards available with different architectures. The choice of microcontroller architecture for a particular project depends on various factors such as processing power, memory size, power consumption, and cost.